Dear students, let's begin second part of our today's lecture, getting ready for data analysis. Okay, after collecting data, you have to get ready for data analysis. So in order to data analyze, you can use descriptive statistics as well as inferential statistics. Descriptive statistics is for your diagnosis test, okay, basic measures. So you can calculate the averages on a variable, then how different scores are from on another. So using, you can calculate the frequency, percentage, then mean, standard deviation, okay, and so on. And for inferential statistics will help you to make decision about your null and research hypothesis, okay. So before collecting data, maybe you have developed, you have designed your null hypothesis and research hypothesis. So now this inferential statistics will help you to decide about your null and research hypothesis. And also it will help you to generalize from sample to population, because you have collected data from population based on your targeted sample size. So now you have to generalize based on your findings about the population, okay. Then descriptive statistics, okay, you can present descriptive statistics using histogram, okay. This is an example of using descriptive statistics. So this diagram shows the distribution of a score. You can see in the diagram there is a several distribution point, data distribution point, like 15, 23, 33. Okay, so this is the math. This is the math score. Okay, and the vertical line you can see the frequency. Okay, so this way, after collecting data, you can use descriptive statistics and you can present your data using histogram. Okay, to show the distribution of your scores, okay, for a specific variables, okay. Then you have to you can calculate, okay, you can measure of central tendency using mean, arithmetic mean. You have to calculate the average, okay, score of your variable. Then also you can calculate the median. Median is the midpoint in a distribution, and mode. Also you can calculate the mode, okay. Mode refers to the most frequent score. I hope you know what is mean and median mode. I don't have to give an example here. Then mean, how you can calculate mean, okay. So the what is mean? Mean is the arithmetic average, sum of a score, okay, number of scores, okay. How to compute it? You can see the x bar is refers to the mean, okay. So how to summation, okay, x. So and x is score of the specific, okay, variable, okay, and divided by n. N refers to the size of sample. So add up all the scores, okay. So which is the x, okay. Then divide the total by number of scores. So how many scores? So let's say you have 200 samples, okay. So you can divide by 200. Okay, then you will get mean. Then mode, what it is, okay. Mode is most frequently occurring score, okay. So what it is not, how often the most frequent score occurs, okay. So this is the way you can identify your mode. Then when to use which measure, okay. So measure of central tendency, level of measurement, when use examples, okay. So you can see the mode, okay. So level of measurement is nominal. So when we use mode, data are categorical. When data are categorical, we can use mode, okay. Example, eye color, party affiliation, okay. These are the example of mode, okay. Then median, okay. So level of measurement is ordinal, okay. So when use, data include extreme scores, okay. When it includes extreme score, we use median. For example, rank in class, okay, birth order, income, etc. Okay, so these are the example of median. Then mean, interval and ratio. Okay, so when we use mean, equal and the data fit. Okay, speed of response, for example, age in years. Okay, so let's say for example in our research methodology class, so we have 170 students, so we have to know the average age of this class. Okay, so we can use mean. Okay, then measures of variability. Variability is the degree of spread or dispersion in a set of scores. Okay, so we can calculate the range, okay, difference between highest and lowest score. Okay, so 2, 3, 7, 9, 10, 11. Okay, so now we can arrange, okay, lowest to highest score. Okay, so what is the difference between highest and lowest? Okay, we can calculate range in this way. Then standard deviation, we can calculate its standard deviation. So standard deviation refers to average difference of each score from mean. So how to compute standard deviation? You can look at this formula, the square root summation, then x minus x bar square, okay, divided by n minus 1. Okay, so n is the refer to the sample size minus 1. Okay, so the summation, okay, the sign, okay, then x is score of the variable, and x bar is referred to the average mean, and n refers to the size of sample. Okay, so you can look at this. Okay, the first list scores and compute mean. Okay, so you can look at this first column, x, okay, refers to the score, okay, individual score. Okay, then how we can calculate? We sum up, okay, all these values. Okay, so x bar refer to the mean value, okay, 13.4. Okay, then second step, subtract mean from each score. Okay, so if we subtract mean, okay, 13.4 from x individual value 13. Okay, you can see the first row 13, okay, 0.4 minus 13, we get minus 0.4. Okay, then third step square is deviation. Okay, so now you square each deviation. Okay, then fourth step sum. Okay, so you can sum a square deviation. Okay, then you will get 34.4. then fifth step, divide sum of squared deviation by n minus 1. So our square deviation 34.4 divided by 9. Okay, because our sample size is 10. So n minus 1 we have 9. So divided by 9. So we have a score 3.82. Okay, 82. Okay, so this is the. Then the next step we need to compute. This is the variance. Okay, so we need to compute a square root of step 5. Okay, so we have a score 3.82. So a square root of 3.82 will have 1.95. Okay, so this is our standard deviation. Okay, then the normal curve, whether our data is normally distributed or not, so we can use this normal curve. So the normal curve is commonly referred to as a normal curve or a bell-shaped curve. Okay, it is also called bell-shaped curve. Okay, so it is the shape that represents how variables such as height and weight are distributed. Okay, so and it has some very interesting characteristics. Okay, so that means, okay, the two halves of the normal curve always mirror one another. Okay, so mean equal median equal mode. Okay, so and it is symmetrical about midpoint. Symmetrical refers to the balanced. Okay, balance both sides, as we mentioned earlier, the two halves of the normal curve always mirror one another. Okay. Then tails approach x-axis. Okay, but do not touch. You can see the tail approach x-axis but do not touch x-axis. Okay. Then the mean and the standard deviation. Okay, you can look at the first figure. Okay, so we have, okay, the distribution of scores can be equal in their variability but very different in their mean. Okay, so if you look at the first diagram, okay, we can see that they have different mean but distribution of score can be equal. But the second diagram, okay, you can see the mean is math score is 50 but is the the peak on is the less variability, and the the flat one have more variability. Okay, so that means the distribution of score can be equal in their mean but very different in their variability. Okay, so regardless of the value of the mean or the standard deviation, if a distribution is normal, you know exactly what percentage of cases in the distribution you can expect to fall where. Okay, then okay, standard deviation and cases. Okay, so you can look at this bell shaped, okay, normal distributed curve. Okay, when you know the mean and standard deviation, you can very accurately determine what percentage of cases falls under certain defined areas beneath the normal or bell-shaped curve. So the normal curve is symmetrical as we mentioned earlier. Then one standard deviation to either side of the mean contains 34% of area under curve. So both sides 34%, 34%, total sum up 68% of score lie within plus minus one standard deviation of mean. Then standard score, computing z-score. Okay, standard score have been standardized so that scores from different distribution have the same different point, the same standard deviation. So how to compute z-score? Z equal x minus x bar divided by standard deviation. Okay, so z stand for standard score, x for individual score, x bar refer to mean, and s refer to standard deviation. So using this formula we can calculate, we can compute z score. Okay, so the standard score are used to compare scores from different distribution, like for example the class mean. Okay, Sarah 90, Mika 90. Okay, how to read this Mika? Or Mika or Misha? Okay, because CAT, but sometimes in Malaysia we use cha, ruti chana. Somebody was asking about, do you have ruti kanai? Because he follow that method, the CAT, so he asked about ruti kanai, okay, instead of ruti chanai. Okay, so you can read it Mika or Micha is up to you. Okay, so then class standard deviation, Sarah 2, then Mika or Micha is 4, then students, okay, raw score is 92 as well as 92. Okay, the same again. How to calculate the how to get what is the z score? Student z score for Sarah 1 and for Mika 0.5. Okay, so what z score really mean? Because different z score represent different location on the x-axis, and location on the z-axis is associated with a particular percentage of the distribution. So z score can be used to predict the percentage of scores both above and below a particular score, and the probability that a particular score will occur in a distribution. Okay, so I think that's all for today's lecture. Thank you very much. We end our class here.